An introduction to moles. Don't scream and run. Moles can be fun. All silliness aside, moles are very important in chemistry. In class today, we talked about common counting units, such as a pair, a dozen, a ream, and a gross, and these are just units that have been developed to count items, and it's counting items in a practical way. For example, you have 2 feet, so a pair is 2. We buy eggs in dozens because that's a reasonable number of eggs to keep in your refrigerator before they go bad. We buy paper in a ream, which is 500 sheets, because we tend to use a lot more paper than we use eggs. Moles are used to count atoms and molecules, which are crazy, crazy tiny. So the mole is actually a huge number of items. Moles are 6.02 times 10 to the 23rd items. How many items is that? If we had a mole of paper clips, we could circle the earth 14 times if those paper clips were all linked together. So moles are used to count crazy tiny things, which is why the number of items in a mole is crazy big. Moles and dozens can both be used to count numbers of items. Moles, however, can also be used to measure mass. Imagine if there was a book that somebody put together where they took the mass of a dozen items and put it in the book. So imagine this book of dozens listed everything you could possibly imagine. How much 12 elephants weighed, how much 12 mice weighed, and maybe even how much the yummy donut weighed. We can see that there's a problem right away with this book of dozens. Look at all the different kinds of donuts. When we say a dozen donuts, are we talking about cream-filled, vanilla frosted, powdered sugar? And certainly they're not all going to weigh the same. So this idea of being able to know how much a dozen items weighs is kind of silly. However, when it comes to atoms and molecules, those things are so similar that counting them by their mass actually makes sense. The periodic table of the elements is just like the idea of a book of dozens. This lists the mass of moles of individual atoms. So if I wanted to know how much a mole of carbon weighs, I can just look up the number on the periodic table. If I wanted to know how much a mass of a mole of water molecules was, I can look up the mass of hydrogen, multiply it by 2, the mass of oxygen, add it together, and get 18. This is called the molar mass, or the mass of a mole of atoms or a mole of molecules. Now you may be asking yourself, why the heck do I care about moles? Well, moles are extremely important in chemistry because they allow us to link the microscopic world of atoms to the real world of chemistry that we do on our bench tops. So we can see here, this is actually an atomic force microscopic picture of atoms. Here are some models of molecules, and here's a mad scientist doing some chemistry at their bench. So when we balance equations and we talk about how many atoms of hydrogen we need to combine with how many atoms of oxygen to form water, we really need a scale in which we can do those experiments in the real world. I can't get 2 atoms of hydrogen and 2 atoms of oxygen and piece them together. So I need a way to measure chemicals that is practical. This is what the mole allows us to do. Here's the equation I just mentioned. If we take hydrogen and oxygen and combine it and make water, we have a basic recipe. However, we're smart chemistry students, so we realize that this recipe has to be balanced, meaning I have to have the same number of each kind of atom on each side of the arrow. So by putting in some coefficients, I now have a balanced equation where I have 4 atoms of hydrogen on each side and 2 atoms of oxygen. So this equation can be read as 2 molecules of hydrogen and 1 molecule of oxygen produces 2 molecules of hydrogen. So the coefficients can equal molecules and atoms. But the coefficients can also equal moles. I can read this equation as 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of water. You may be saying, how the heck did she do that? Well, let's say I multiplied this entire equation by 12. So then I would have 24 hydrogens plus 12 oxygens yields 24 waters. Well, look what that tells me. This is 2 dozen plus 1 dozen gives me 2 dozen. And I could do the same math if I multiplied it by 6.02 times 10 to the 23rd. So the coefficients can be read in terms of molecules, dozens, or moles. And why is that useful? I can link moles to grams, and grams I can measure on a balance in the lab. So in order to take my equation on a piece of paper and go back to the balance and measure out the right number of chemicals, I have to be able to convert from moles to grams and back again from grams to moles. Don't panic. Think about how you handle this concept with the term dozens. If you have 48 eggs, how many dozen do you have? Well, in your head, you're probably saying, okay, I'm going to take 48 and I'm going to divide it by 12, the number of items in a dozen. If I have 3 dozen items and I want to, 3 dozen eggs, and I want to know how many that is, I'm going to multiply by the number of items in my counting unit, or multiply by 12. We do the same exact concept when we're converting with moles and grams. So here's our first practice problem. Let's say I want to convert from moles to grams, and I happen to have 3 moles of carbon, and I want to know how many grams it is. Well, in order to solve that, I need to think about my dozen problem. If I had 3 dozen eggs, and I wanted to know how many eggs it was, I would multiply by the number of items in an egg, or 12. So for our problem, we're trying to figure out how many grams are in a mole. Luckily for us, the periodic table tells us there are 12 grams in 1 mole. So if I have my 3 moles and I multiply it by my 12 grams in 1 mole, I end up with 36 grams of carbon in 3 moles. Our second example involves going from grams to moles. And in this example, if I have 25 grams of helium, I want to know how many moles that is. So I'm going to go back to my good friend, the periodic table, and I find out that 1 mole of helium weighs 4.0026 grams. And I'm going to be lazy, so I'm just going to say it weighs 4 grams. So if I take my 24 grams of helium, and I'm now trying to figure out, do I multiply or divide? So let's think about our dozen example. If I had 24 eggs and I wanted to know how many dozen it was, I would divide by 12. So here I'm going to divide by the number of grams in a mole of helium. So 4. So this gives me 6 moles of helium. So just like the dozen, I take my number and divide by the number of items in that unit, and I get my answer. Not so scary. So when all is said and done, moles are a very important concept in chemistry. With a little bit of thought, we can appreciate how moles allow us to count very, very tiny atoms and molecules, and they allow us to link a balanced equation on a piece of paper to things that we do in the lab. We're going to get a lot of practice on this idea of moles, and when we practice, we'll realize that these moles aren't so scary and that they're actually quite useful.